Hey guys, so today what I'll be doing is I'll be recapping this chapter, actually doing a quick review through it. Linear inequations, class 10th, ICSE syllabus. Now one thing let me tell you, this chapter has a lot of hype, but it is nothing. Okay, very easily. हम chill marker पूरा chapter सीखेंगे, ठीक है? So let me tell you, if you know this, no, 5 marks are guaranteed in board. One 4 marker inequality somewhere or the other you have to see in your paper, and one MCQ though will for sure be tested. So if you know this chapter, it is a major advantage for you only in the board exam. Let me tell you that. So what are linear inequations? Before we actually get to that, let me introduce you to the syllabus first of all. So what are we going to learn? We are going to learn to solve inequations regarding one variable. Then we'll learn about solution set notation. First of all, what is an inequation? We'll learn all that. Then we'll learn the difference between an inequation and an equation, all that we'll learn. Then we will learn how to represent a solution set, how to write a solution set. Then we'll be learning a little bit about sets, then notation set we have, what else, replacement set we have. Then last but not the least, this is the main thing that the board asks, representation on a number line. How to represent any inequality on a number line, that also will study properly. Okay, so now that you guys know the syllabus, let us quickly begin with the chapter without wasting any more time. Okay. Now, when I say the word inequation, what is the first thing that comes in your mind? Equation, right? Because not only do they sound alike, let me tell you, they have the same function. Okay. Now, if you look at what an equation is in mathematical terms, it is just an expression that equates two variables, constants, anything. It just equates two different values / expressions. Now, over here, you learned so many things, right? You learned quadratic, you learned linear, you learned componendo, dividendo. All those places in algebra, mostly you have something called an equal to. What does this equal to indicate? This equal to just indicates that LHS is equal to RHS. Ultimately, that is the main funda that we need to remember. LHS is equal to RHS because of that equal to sign that is present. Getting it? So this equal to sign is our hero. That is our indicator that it is an equation. So without that equal to sign, it just becomes a regular expression. So what does an equation do basically? It just provides a relationship between LHS as well as RHS. Now, I'll give you an example. Let's say x squared plus 1 is equal to 5. Right? X squared is basically equal to 5 minus 1, that is 4. X is equal to plus minus 2. Getting it? This is the example of an equation that we have. Now, equation is basically when one value is equal to the other value, when they are equating each other. But to explain that, first of all, okay, let's say tan 45, and then we have cot 45. Now, tan 45 and cot 45. Both of them have one value. What is that value? 1. Tan 45 is 1. Cot 45 is also 1. Is it or is it not? So I can say tan 45 is equal to cot 45. This right here becomes an equation. But let us say, okay, 45 and 46. Can I say that 45 is equal to 46? No. 45 is not equal to 46. So we can say 45 is not equal to 46. But the thing is, this doesn't tell me much. It just tells me they are not equal, which I already probably knew, right? This just tells me that they are not equal. So I don't want this is not equal to this. I want a proper relationship. So how do I get a proper relationship? That is when we use an inequation. So an inequation is basically greater than, lesser than, greater than or equal to, less than or equal to. So tell me, 46 is it greater than 5? Yes, 46 is greater than 5. This you've had in lower classes also. 46 is greater than 5. Crocodile come out will point towards 46. Right? You've had this even in lower classes. Basic this is here. So 46 is greater than 45. So this right here is a simple inequation that you guys have. So in simple words, an inequation is a statement that compares values or expressions that are usually not equal. So ultimately, equation equates, inequation compares. Basics. Getting it? Equation will equate, inequation will compare. 5 is equal to 5. What is that? It's an equation. But 5 is greater than 4. That is an inequation. You've compared two values that are different and you've said 5 is greater than 4. What are the different inequality signs you'll come across in this chapter? You have 4. Greater than or equal to, less than or equal to. Now greater than or equal to, less than or equal to is generally used when one value is unknown. Let's say x. We have any variable x. X can be greater than or equal to 4. What does that mean? X can be 4. It can be 5, 6, 7, 8, 9, 10 all the way up to infinity. Similarly, less than 4, if it has to be 3, 2, 1, 0 all the way up to negative infinity, right? Less than 4, greater than or equal to 4. In that case, x is unknown, but we don't use it for known variables. Like for example, you can't say 16 is greater than or equal to 4. That's a stupid statement. 16 can never be equal to 4. Yeah, it's always greater than 4. So we usually use this when one value is unknown or when it is a variable. That is when we use less than or equal to, greater than or equal to. Now, inequation signs, so you know, equation you know, inequation you know, difference you know. Main thing is that. Now, the thing that will come in your mind is, oh, ICC gives such complicated looking inequations. How do I solve them? It's a question that comes in your mind. Well, you're not wrong. It gives complicated looking inequations. But yeah, just try solving them. You have inequations in one variable. That is an added advantage. Basically, just like linear equations only. There's nothing to do basic algebra knowledge you need for it. You'll be able to solve it. You just need to know how to solve inequations. That is pretty much it. Now, when you're solving any equation, you have some basic rules and regulations you guys follow. If LHS means something is in the denominator, RHS means if it goes in the numerator. If this is addition over here, it goes there, becomes subtraction. Here, if it's division, goes there, becomes multiplication, vice versa. Correct? Certain rules and regulations. Similarly, if you reciprocate this, that also gets reciprocated. Whatever you're doing on this side of the equal to, you're doing on that side of the equal to also. Basic things related to equations, these are. So whenever you're solving equations, you have certain rules and regulations. Same with linear inequations. Inequations also have certain rules and regulations that you guys need to follow. Now, they are a little different from equations, but more or less they are the same. So let's go over the rules. Now, rule number 1, whenever you have to solve any inequality by equal numbers may be added or subtracted from both sides of the inequality without affecting the sign of the inequality. Very, very simple. For instance, you have x plus 7 is greater than 3. You have this inequality right here. What does this indicate? Basically, just treat it like a regular equation. X is greater than 7 goes to that side of the equal to. 3 minus 7 becomes what? Negative 4. So x over here is greater than negative 4. Similarly, if it was x minus 7 is greater than 3, what would it have been? X is greater than 3 plus 7 because minus 7 will go to the other side of the inequality, change its sign. Getting it? So the same thing, just like you do in an equation, you do in an inequation with positive, negative. If addition, subtraction may, you're doing it, inequality sign will not get affected. Now you need to be very, very careful with this inequality sign. This inequality sign that is there, this inequality sign, it can change. It doesn't always remain the same. It can change. Now I'll tell you when it changes also. When you're adding, subtracting positive numbers, even negative numbers, it will not. Ultimately, if you're adding a negative number, it will become subtraction, right? So adding and subtracting numbers may, it will not change. Now here is the thing, multiplication and division. When you're multiplying, dividing positive numbers, it will not change. How do you solve this inequation? 3x is greater than 20 times 2, which is 40. 3x is greater than 40. X over here is greater than 40 divided by 3. Done. This inequation we've solved. That means inequality sign will not change, even if it is division. If this thing is 3x over here, you've gotten 3x, you've sent this 3 down here, right? This inequality is still not changed. Inequality will remain the same. When you're adding, subtracting numbers, inequality sign will not change. Multiplying, dividing positive numbers, it will not change. But here is when it changes. When the inequality is divided or multiplied by any negative number, that is when it will change for sure. Negative 6x is greater than 48. How do you isolate x basically? You divide by negative 6 on both sides of the equal to. In this case, both sides of the inequality, you divide, right? So this thing will go how many times? Negative 8 times. Now x is not greater than negative 8. X over here becomes lesser than negative 8. Now all these rules, I will verify. Don't worry, I will verify them. I'll tell you why they change. Okay, I'll verify them. Now there are 2 more rules you need to follow. When you're reciprocating both sides of the inequality, that is when the inequality sign will also change. Similarly, if you're interchanging the signs, basically multiplying both sides by -1, multiplying both sides or dividing both sides by -1, multiplying or dividing by any negative number, inequality sign changes anyways. So when you change the signs also, they will change. When you're reciprocating them also, they will change, right? So verification, I'll tell you. So let's say you have 2 known quantities, 6 and 4. 6 is obviously greater than 4. This becomes our inequality, right? So now let's say you're adding 2 to this. You're adding 2 to this also. 6 plus 2 is 8. 4 plus 2 is 6. 8 is still greater than 6. Similarly, minus both sides by 3. 6 minus 3 is what? 3. 4 minus 3 is 1. 3 is greater than 1. This also, multiply both sides by 5. 6 into 5 is 30. 4 into 5 is 20. 30 is greater than 20. Inequality sign will not change. Divide both sides by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. 3 is still greater than 2, right? Inequality sign will not change when you're adding, subtracting, multiplying, dividing by positive numbers. When will it change then? It changes when you're dividing by any negative number or multiplying by any negative number. So let's say you're dividing both sides by -2 instead of just dividing it by 2. 6 divided by -2 is -3. And then 4 divided by -2 is -2. Now, as you can see over here, -3, -2. What is greater? -2 is greater. So inequality sign changes. In a number line, -3 comes before -2, doesn't it? So therefore, -2 is greater than -3. So in this case, -3, inequality will shift to -2. So this is when I've divided. Let's say you also multiply. When you multiply also, inequality sign will change. Let's say this side is 6, this side is 4. 6 is greater than 4. Multiply both sides by -5. -5 into 6, -30. -4 into 5. That is what? -20. -20 is greater than -30. Inequality sign will shift to -20. Getting it? Adding, subtracting, multiplying, dividing, it does not change. Multiplying or dividing by any negative number, that is when it changes. When else does it change? When you're reciprocating. If you've reciprocated it, 6 is greater than 4. But 1 upon 6 is not greater than 1 upon 4. 1 upon 6 is not greater than 1 upon 4. Basic fractions, this is by. Let's say you have a pizza. You divided the pizza into 4 slices. Second pizza, you divided it into 6 slices. Which slice will be bigger? In which pizza? The pizza in which you have divided it into 4 slices, right? Because the quantity of each slice will be more. So based on fractions also, if you reciprocate both sides of the inequality sign will shift. Now you know basic rules. Adding, subtracting, multiplying, dividing positive numbers doesn't change. Multiplying or dividing by negative number changes. When you're reciprocating both sides, then also inequality sign will change. Are you getting it? So let's say you have 1 upon x. Let's say you have 1 upon x is greater than 6 by 9. 1 upon x is greater than 2 by 3. So now you want to reciprocate both sides. X over here becomes less than 3 by 2. Inequality sign will change when you reciprocate both sides. Are you getting it? I hope you're getting it. So yeah, now I've verified. I've told you what an equation is, difference between an equation, main funda of an equation, what does it do, compares to expressions / values. You know all these things now. Now the main thing you need to understand that whenever you solve any inequation, you get something called a solution set. Solution set you also learned in quadratic, right? Like in a quadratic, there's always 2 values of x, 2 roots. So therefore there are 2 solutions, so 2 elements present within that set. We form a solution set even in quadratics. Similarly, when you're solving any inequation, you have a solution set that you guys need to form. Other than that, you also have something called a replacement set as well as a notation set, which I will explain to you. To solve the following, now so you know. See, ultimately when you solve any linear equation, what do? Take all the x's to one side, take all the constants to the other side. That's exactly what we're going to do over here. So what we're going to do is we're going to take the x over here, make this negative x. So -2. -2x minus x is greater than or equal to -12 minus 3. So this becomes -3x is greater than or equal to -15. Divide both sides by -3. Inequality sign will shift. This thing cancels with this. This thing cancels with this. So x over here is less than or equal to 5. Now they have also said that x, for instance, it belongs to the set of natural numbers. X is less than or equal to 5, and x belongs to a set of natural numbers. How do you write the solution set for this? Think about it logically. First of all, what are natural numbers? Start with 1, go up to infinity. That too you know. Now if it is less than or equal to 5, end point is what? 5. So it starts with 1, ends with 5. Solution set is basically what? 1, 2, 3, 4, and 5. This is our solution set. If this was not equal to, if this was just less than, then it would end at 4. Getting it, but in this case, it ends at 5. So now you know how to solve a basic inequation, that too you know. Now let's say you also have this x belongs to natural numbers. That means x belongs to a set of natural numbers. This thing over here is belongs to. This sign over here is the belongs to sign, or is a part of. So x is a part of a set of natural numbers is basically what this belongs to sign indicates. Okay, so now that much you guys know, right? So now let us move on to the next concept, that is sets. Now you know what a solution set is. Every inequality has a solution set, but there's also something called a replacement set and there's something called a notation set. Notation set is easy, that's not that important. Replacement set is what is important. Can come in theory. Okay, assertion-based questions also can come. Even though this is a very logical chapter, lots of application and all won't be there. See, there's a fixed amount of questions. Either they'll just give you an inequality, ask you to solve it, or tell you to find the relationship between the solution set as well as the inequality in MCQs, right? They'll tell you to do those things. So now what are sets? Basically, sets are like, how do I explain what sets are? Sets are like a bunch of numbers. Just learn it like that for now. A set is basically just a bunch of numbers. When something belongs to a set, that is a part of that set. Got it? So solution set means x is a part of that solution set. So let's say the solution set is 1, 2, 3. That means there are 3 solutions. X belongs to the set 1, 2, 3 means x can either be 1, either 2 or 3. So that can be the value of x. Now we have this inequation over here. X is less than or equal to 4 and x belongs to a set of natural numbers. That means x is less than or equal to 4. So what is the solution set that we have obtained? Natural numbers means starting point is 1, ending point is infinity, but it says less than or equal to 4. So 1, 2, 3 and 4. Now this over here is our becomes our solution set. So there are 2 sets actually we are talking about. But if you notice very carefully, there are actually 2 sets. This is the first set of natural numbers. And this right here is a solution set. Got it? So this set over here, x belongs to n. This is an infinite set. It goes all the way up to infinity. So this over here is called the replacement set. Getting a replacement set generally is infinite. But then this over here is our solution set. Replacement set is just telling us that, okay, x, it somewhat tells us where x lies in the number line. But again, that does not help much, right? Because it just says, okay, x belongs to a set of natural numbers. So we know that x starts at 1, okay. Negative infinity, that is ruled out. So x starts at 1. But again, it goes up to infinity. It can be 69 million also, right? We don't really know. So that doesn't help much. But for that, what helps? The inequality helps. The inequality is basically like a limit. This limit basically tells us that, okay, the solution set has to be within this range. So that is the difference between a replacement set, solution set. Replacement set is generally infinite. It just tells us x belongs to a set of natural numbers. X can be anything. But an inequality helps us, break the replacement set into the solution set. To explain this concept further, I'll give you an example. Let's say you're going to a library. Let's say you're going to a library and you want to buy a book. Now you take your book as x, a variable x. Now the book has to belong to the library. Okay, book has to belong to the library. Now the library has so many books. Some 10,000 books are there in the library. So you don't exactly know which book you're buying. But the book that you're going to be buying is from the library or it belongs to the library. But the moment you check your list and set and you see that, oh, you've read everything except Harry Potter, that means only 8 books will be left. If you include Cursed Child, or if you don't include Cursed Child, there'll be 7 books. Basically, it's a set of 7 books that you need to look from. So all the books in the library, that becomes your replacement set. But Harry Potter books in general, that becomes your solution set. So the book that you're going to be buying, it's Harry Potter, so it has to be 1 out of the 7 books. So that is your solution set. Basic. Understand difference between replacement set, solution set. Okay, so now what is a notation set? Notation set is just a different way of writing it. Okay, let's say you've been given the replacement set and solution set, but you've not been given the inequality. First, just copy the curly bracket as it always represent any set with a curly bracket. So copy this as it is, copy the replacement set as it is, x belongs to whole numbers, put a semicolon, and then you need to write the inequality. 0, 1, 2, 3, 4. So it has to be less than 5. X is less than 5. Or you can also say x is less than or equal to 4. You can also say that, both satisfy. So this right here is our notation set. Okay, it's just a different way of representing this. If you've gotten a replacement set and solution set, basically just a way of depicting the replacement set and solution set. So now you've understood what an inequality is, how to represent an inequality, what are rules to solve inequalities. I'll go over it again. Adding, subtracting, multiplying, dividing, nothing changes. Inequality sign will remain the same. Reciprocating may 100% inequality sign will change. Multiplying and dividing by negative coefficients, it changes. Got it? So all this is done. Now here are some things you need to remember. Okay, replacement sets are some criteria. If x belongs to n, n indicates natural numbers. Natural numbers are what? 1 all the way up to infinity. X belongs to w, talks about whole numbers. So 0 up to infinity, it's a whole number. And x belongs to integers. That means negative infinity all the way up to infinity as long as it's a whole number. Now real numbers can be anything. X belongs to R is real numbers. It can be fraction, decimal, irrational, anything. And then we have x belongs to q. This is generally for rational, and x belongs to I is for irrational. But usually what ICSE does know is that they use I even for integers. Okay, they use I even for integers. So you shouldn't really get confused that much. These 2 things are not really that important right now. These 4 are the main things you need to know. This is where questions come from. Got it? Now one last concept, let me tell you, how do you represent any inequation on a number line? Let's say you have any inequation like this, x is less than 3. How do you represent it on a number line? How do you represent it on a number line? This is our number line over here. First, mark 0, 1, 2, 3, -1, -2, and -3. And then we'll say that x belongs to whole numbers. So we've gotten the criteria, we've gotten the replacement set, x belongs to a set of whole numbers, and we've gotten the inequation. How do you plot this on a number line? Whenever you have less than or greater than, always you have to put a circle. So how do you mark this? First of all, x is less than 3, so it has to be 2. Circle 2, just circle it. But the moment I say x is greater than or equal to 3, that is when you circle 3 and you also shade it. Because if you just simply circle it, then they'll think that, okay, it can also be x is less than 4. So greater than or equal to or less than or equal to, that is when you shade it, circle it and shade it. If it is just less than or greater than, you need to just circle it. You need to take care of this, okay, because board takes it seriously, right? We don't want to mess with the boards because they'll really screw us up. But this part, though, at least I hope you understood. So how do you mark it on a number line? X is less than 3 and x belongs to whole numbers. X belongs to whole numbers means end point is what? End point is 0. So you circle 0 like this, okay, and then you circle 2. And then you basically just shade it like this. Done. Actually, wait, I don't think you need to shade this, right? You don't need to really shade 0. But this is how you represent it on a number line. Now, let's say it's not whole numbers and it's integers. Integers are all the way up to negative infinity. So basically, you start with negative. You basically start with 2. Shade this entire thing, even this arrow. Goes all the way up to negative infinity. Only criteria is it has to be lesser than 3. Means it has to start with 2. So just circle 2. This is how you represent it on a number line. If something is greater than or lesser than, just directly circle. If something is greater than or equal to, less than or equal to, you need to circle it, shade it. Got it? Okay. So now I think you guys are prepared enough, basic rules and all that. So now we can sit and solve the board questions. If you're able to solve this now, then you'll be able to solve the questions. Don't worry. I will also be doing with you guys some practice questions from this chapter. So don't need to worry. Okay, so we've gotten this inequation over here. Solve it, write down solution set represented on the number line. Now we've gotten the replacement set, that is x belongs to I. Now I over here can mean integers, it can mean irrational numbers. I think it's just integers. I think they mean integers. They should have written z, but that's fine. So see, whenever you have 2 inequality signs, whenever you have less than or equal to and then less than, basically solve one part first. Solve this part first. You call this A, call this B, and call this C. Solve A and B together, then B and C together. Solve this first, and then solve this after that. So this is how you solve it. Are you getting it? And after you do that, then you plot it on the number line. So first, let us solve the first part of the inequation. Negative 3 plus x. See, ultimately, why are we separating it into two parts? Because you have to have a starting point and an ending point, usually in your board questions, right? If you don't have that also, it's fine because you have to then, go and shade that arrow and all, you can do that. But usually in the boards, you have a starting point of the inequation and an ending point of the inequation. So to solve the first part, negative 3 plus x is less than or equal to, we have 7x divided by 2 plus 2. Okay. So now just like I say, get the x's to one side, constants to the other side. So I'm getting all the variables here. X minus 7x by 2 is less than or equal to 2. And then this becomes plus 3. So that's 5. Find LCM now. X times 2, that's 2x minus 7x divided by 2. This thing is less than or equal to 5. Okay, so this is negative 5x over 2 is less than or equal to 5. So now what you can do is you can multiply both sides by 2. That's exactly what you need to do to get rid of this 2 in the denominator. See, it's positive, so you're multiplying by positive numbers anyway. So negative 5x is less than 5 into 2, that is 10. So if you're dividing both sides by negative 5 now, what happens? Inequality sign will change. So since inequality sign will change, this cancels with this. This cancels with this becomes negative 2. So x is greater than or equal to negative 2. Okay, so the first part of the inequation we've gotten. X is greater than or equal to negative 2. So now let's solve the second part of this inequation. We'll solve 7x divided by 2 plus 2. 7x divided by 2 plus 2. This thing over here is less than, we have 8 plus 2x. 8 plus 2x. Same thing we will do, take all the x's to one side. 7x by 2 minus 2x. This thing is less than 8 minus 2, sorry. So 8 minus 2 is 6. Again, take LCM. 7x minus 4x divided by 2 is less than 6. Take the 2 up. 7x minus 4x, so anyways is 3x. 3x is less than 6 into 2, that is 12. So divide both sides by 3. You're dividing by positive numbers, so inequality sign will not change. Divide both sides by 3, and then 3 gets cancelled over here. This goes here 4 times. So now what becomes the final inequation? Final inequation, if we have to solve, x over here is greater than negative 2 and x is lesser than 4. Sorry, wait, it's greater than or equal to now. So greater than or equal to negative 2. So now this we just need to sit and plot on the number line. Quite simple. So let's plot it. So we have been given that x is greater than or equal to negative 2. If it's greater than or equal to, always shade it. Shade it like this. What I like to do is draw it like this. This number line though you need to draw yourself with a pencil. But yeah. Okay, so you've shaded it and then it is less than 4. That means it is 3. So we don't shade 3. We just write this and then we can connect it. Connect it using a line like this. X lies between which 2 points? Negative 3 and 4. So x is negative 2, negative 1, 0, 1, 2, 3. How many solutions are there totally? 1, 2, 3, 4, 5, 6. 6 solutions are there totally, including 0. So you understand it's actually a lot easier than you think. If you're multiplying, dividing by negative number, only then the inequality sign will change. And if you're reciprocating it, then also inequality sign will change. Otherwise, everything is the same. Just like solving a regular linear equation. Okay, so now let us solve this inequation. We'll deal with this part first and then we'll deal with this part after that. Now x belongs to real numbers. This means x can be some decimal. Okay, it can be 2.7, it can be 3.14, it can be any of those things. Rational, irrational. So first we'll deal with this side as I said. 2x minus 5 by 3. This thing is less than 3x over 5 plus 10. So take all the x's to one side. 2x minus 3x by 5 is less than 10 plus 5 by 3. Alright, so yeah. Now what you can do is take LCM. 5 times 2x, that becomes 10x minus 3x by 5. This thing is less than 3 times 10 is 30. 30 plus 5. So 35 divided by 3. So over here we have 7x divided by 5 is less than 35 divided by 3. 3 times 7x is just 21x. This thing is less than 5 times 35, that is just 175. Because it's 350 divided by 2, that's what I did. And then divide by 21 on both sides. So x ka value is what? 75 divided by 21, that's a little more than 8. It's 1/3 of, so 8.333. It has to be 8.333. So as I told you, it is just an irrational number. But it's not equal to, my bad, it's less than. So x is less than 8.333. This is the first part that you've gotten. After that, what will you get? You can represent it as a fraction, I'm telling you, that's better. 8 1 by 3, represent it like this. Okay, so now we've gotten one part, we've got that x is less than 8 1/3. Now we basically need to get what x is greater than. So it's basically, we'll take the second part of the inequality, 3x by 5 plus 10. 3x by 5 plus 10, this thing over here is less than or equal to. And now basically just get all the x's to one side, constants to the other side. 3x by 5 minus 4x by 5. This thing is less than or equal to 11 minus 10. So we have 3x minus 4x is minus x. Minus x by 5 is less than or equal to 1. Take the 5 over there. Negative x is less than or equal to 5. If you want to flip the signs over, x is greater than or equal to negative 5. So now you know the range basically. You know the final solution. X is greater than or equal to what? X is greater than or equal to negative 5. And you know that x is less than 8 1/3. So all you need to do is represent this inequality on the number line, which is what we're going to do. Now since this is greater than or equal to we have to circle it and then shade it like this. And since this is just less than, it'll be somewhere over here. It's just less than, so we'll just have to circle it. It's a little before this actually. See, between two whole numbers, there's an infinite amount of real numbers, so it can be just right before 8 1/3 also. So yeah, if we show this much, it's enough. Circle this. All right, and now all you need to do is just connect it. Yeah, and that's pretty much it. Now if you want, you can basically shade this number line. So now we have this inequation. I want you guys to do this by yourself as a homework. 4x minus 19. Again, same thing. Take this first, deal with this, then you deal with this. And then you get the final inequation and then represent it on a number line. So these are all board questions, by the way. These are board questions, specimen paper questions. Okay, so if you solve it, then you'll get a very good practice of it. Now over here, I have a linear inequations wala test. So we'll be solving all the difficult ones. 4, we'll solve 5, then we will solve 7. These 3 questions I'll solve, but I'll do it in the next session. I'll do this along with questions from ratio and proportion, banking, matrices also, and even remainder factor theorem if I can. Entire algebra part, except for AP, GP, and quadratic, entire algebra part I'll solve. Got it? So these 3 questions I'll be solving. You can also solve them right now if you want. You can take a screenshot of this test. Solve it by yourself. It's a 20-marker test. You'll get a good revision of the chapter.